All right, now we're going to do angled launch with a maximum height. So in this case, I was given the initial velocity of 20 meters per second that a soccer ball was kicked at an angle of 30 degrees. I want to know how high did it actually make it. Now we're going to neglect air resistance in this case. And the key important thing to note here is when we have maximum height problems, at the maximum height position, the vertical velocity is 0. Okay, so that's what we're going to use. So we'll note that the ball is moving in both the x and y direction. So I have two-dimensional motion. So I'm going to list those variables, remembering that the time is the same in both directions. This is also projectile motion because the ball is moving in the x direction but in free fall in the y. So I have a 0 meters per second squared acceleration in the x, negative 9.8 meters per second squared in the y. The 0 tells me these two will be the same and that I'm stuck with the equation x equals x naught plus v naught xt plus there's no acceleration term. All right, turns out, little hint here, that when we do max height problems, sometimes we don't have to do anything with the x direction, which is kind of cool. All right, so it's also angled launch. So not only is it 2D motion, we list our variables, it's projectile motion, so we know our accelerations, but it's also angled launch. So this is what we have to do for angled launch. We have to resolve the initial velocity into components. Okay. So here is my situation. I need to resolve that into an x component, v naught x, and a y component, v naught y. Because my system here, with the list of variables, these are all components of position, velocity, and acceleration. The only one that's not a component is time, and that's why it's the same in both. So I do need to find these components. So just like we did when we do vector addition or other angled type problems, we have to resolve a vector. So this one is going to use cosine because it's adjacent. So I get v naught cosine of 30 is equal to v naught x. This one, opposite the angle, I'm going to use sine. So I get v naught sine of theta. And so I can take these and I can put them in here. So this one is then 20 cosine of 30, and this one is 20 sine of 30. Now, if you've memorized your unit circle, that will stick out to you like a sore thumb. All right, what else do we know? Well, I'm trying to find max height. So max height tells me that this value is 0 meters per second for the final velocity in the y direction because it's a max height problem. Okay. The other thing we have to do is we have to choose our coordinate system. So where should I choose based on the information I'm given? So this is where I start. This is where I end. So I'm going to choose the leftmost point as x equals 0 and the lowest point as y equals 0. There we go. So it starts at 0, 0. And we're trying to find the max height, so that is that variable. And I look in my y direction and I know everything but time, and I'm trying to find y. So I'm going to pick equation without time. Equation without time for us is number 3. So I have vy squared is equal to v naught y squared plus 2ay y minus y naught. So crossing out that 0, so vy is 0, the initial position is 0, and now I'm solving for this y. So I got to move this v naught y, which is 20 sine 30. If we plug that in a calculator, it is 10 meters per second. All right. So now I have 0 is equal to v naught y squared plus 2ay times y. So I'm going to have to move this over. It's 10 squared. And it's going to be negative. Now notice that negative sign is outside of that square. Equals 2 times negative 9.8 times y. The negatives cancel. And so here I have 100 divided by 2 times 9.8, which is 19.6, gives me my y value, my final height, my maximum height, which is 5.1 meters. So around 15 feet for a big soccer kick seems pretty reasonable.